Welcome to this video on the equation for a rectangular hyperbola. It also includes the equation of the tangent and normal. Okay, first up, what's a rectangular hyperbola? Now, you have seen these graphs before. It looks something like this. Okay. So you recognize this from a y equals 1 over x, or y equals a over x. Now, as a parametric set of equations, this is x equals ct and y equals c over t, where c is just a constant there, a positive constant. And then the Cartesian equation of this curve is xy equals c squared, okay, or y equals c squared over x, hence the 1 over x that I alluded to in the beginning. Now, this equation has asymptotes at x equals 0 and y equals 0. And then the general point, like on any of these, is just xy, which we can also write as ct c over t. Now you guys know what one looks like. Let's get into a question and work out like the tangent, the normal, and all those lovely things that you may have to do with these. So here we have the point P, where x equals 3 lies on the rectangular hyperbola H, with equation xy equals 27. So find the equation of the tangent. So first, let's look at h. Xy equals 27. Now, what I want to do is just rearrange this. So y equals 27 over x, or y equals 27x to the minus 1. Now I'm going to rearrange it so that I can differentiate it. Now, I'll just differentiate this first. So minus 1 comes down to minus 27x to the minus 2, or minus 27 over x squared. Now you could, from this step, differentiate using implicit differentiation. Now that's something that you cover in P4. So if on your course you do the whole of the regular maths first, P1 to 4, etc., first before doing further maths, then you could use implicit differentiation here. If you're on a course where you're running your regular maths and further maths at the same time, then you won't be on P4 yet, so you don't know about implicit differentiation. So in that case, do it as I'm doing now and rearrange. Anyway, we got out dy by dx equals minus 27 over x squared. Now x is 3. So dy by dx is minus 27 over 9, which is negative 3. Also, when x equals 3, xy equals 27. So 3y equals 27, y equals 9. So P is the 0.39. So now we've got the gradient, minus 3, and we've got the point, of P, which is 3, 9, we can now go ahead and find the tangent. So the tangent T is y minus y1 equals x minus x minus x1. So that's y minus 9 equals negative 3x minus 3. So y minus 9 equals minus 3x plus 9. So y equals 18 minus 3x. Just swapping my constant with my x term there just because of the minus, but of course you can write minus 3x plus 18. Okay. Alternatively, we could put it in the form ax plus by plus c, so we could put it in the form 3x plus y minus 18 equals 0. So either form there. So that's the tangent to the rectangular hyperbola. Nothing too difficult with that. Next, we're going to find the normal. So we've got the P is 3, 9, and the gradient of the tangent is negative 3. That means the gradient of the normal is positive 1/3. So now I can go ahead and find the normal equation. So it's y minus y1 equals mx minus x1. Now, it's always best to write this out. Not so much, you don't need to for an exam. But when you're starting out, writing this out every time you use it, eventually it'll become second nature. You won't have to go away and learn this. It'll already be stuck in your head. So my tip is to always write it out whenever you use it. So filling in for P and the gradient of the normal. Now this is 1/3. We could multiply by a third, have a third x minus 1, but when we see a fraction, unless stated otherwise, it's nice to do it in ax plus by plus c. So I'm going to multiply by 3, so I get 3y minus 27. So I've multiplied by 3, and now I'm going to multiply 1 by x minus 3. That'll leave with x minus 3. Now taking to the side of the positive x's, we got x minus 3y. Then I'm adding 27 to my negative 3, so plus 24. And there we have it, the equation of the normal. So far, so good, nice and easy. Let's have a look at another example. So this one, we've got a parabola, so not a rectangular hyperbola. We've got a parabola and we are finding the tangents to that parabola. So part A is find the coordinates of A and B. So they both lie on the line x equals 2. So our x is going to be 2. So substituting that into y squared, we get y squared equals 16, y equals plus or minus 4. Now, in the question, it says that at A, y is greater than 0. So that means A is the coordinates 2, 4, and B is the coordinates 2, negative 4. Now, part B asks us to sketch C. So it's a parabola. So it's going to look like this. We've got the coordinates, so that'll be 2, so this will be A, and this will be B. So 2 minus 4, 2, 4, that's going to be 0 there. We've also got to put in our lines for L1 and L2. So L1 is the tangent to A. L1. And L2 is the tangent to B. L2. Obviously use a ruler for that in the exam if you were, gonna be asked a question like this. Now let's get on to C, finding the equations of L1 and L2. Now we've got the equation y squared equals 8x. Again, if you have completed the course for the regular maths, this is in P4, you can differentiate straight from here. Okay, however, if you're running this alongside, you'll need to square root it. So I'll do that method. Square root 8x plus or minus. So that is plus or minus 2 root 2x to the half. And then differentiating, bring the half down, so plus or minus root 2x to the minus a half, or plus or minus root 2 over root x. Now, I kept the plus and minus in, so if we look at L1, that's got a positive gradient, and if we look at L2, that's got a negative gradient. So L1 will need the positive version of this, and L2 will need the negative version of this. So at A now, so we're working out L1. So dy by dx equals plus root 2 over root x. I can put that as a single square root as well. So root 2 over, and x is 2, root 2, so that is 1. So the gradient of the tangent is 1 at A. So y minus y1 equals m, x minus x1, so that's y minus 4 equals 1, x minus 2. So y equals x plus 2. So that is the tangent of L1. Now we need to go ahead and find the tangent of L2. This one's a negative gradient. Now at B, we're finding L2. So at B, dy by dx equals minus root 2 over root x, which therefore is minus 1. So our nt for our L2 is minus 1, and our coordinate is b equals 2 minus 4. This one was obviously a is 2, 4. So y minus y1 equals m, x minus x1. So y minus minus 4 equals minus 1 x minus 2. So y plus 4 equals minus x plus 2. So y equals minus x minus 2. Okay, and there we have our two equations for our two tangents. Nice and straightforward. Now, if you are finding the video useful so far, smash that like button now. If you have yet to subscribe to my channel, hit the subscribe now. Obviously, you know it's free, you're not stupid, but it does help me out and it helps my channel grow, which would be useful. So please hit that subscribe button. Now, I'm going to give you a couple of questions and then we're going to come back to a couple more examples. So here's two questions for you to have a go at. Don't forget, after I go through the answers, there will be some more examples and some more questions to follow. So pause the video now, have a go at these, and here come the answers. So first step is to find the equation PQ. So first let's find the gradient. And that is the difference in y's, so 12 minus minus 6, different over the difference in x's, 4 minus minus 8. So it's this one over this one, take away this one basically. So that gives me 12 plus 6, 18, 4 plus 8, 12. 6 goes into that 3 times, 6 goes into that twice. So my gradient is 3 over 2. Then y minus y1 equals mx minus x1. So y minus, now I'm going to use point P. So it's 12, 3 over 2, x minus 4. Now we've got a fractional gradient, so I'm going to multiply it by 2 anyway, but also the question tells me it wants it in this form. So multiplying by 2, I get 2y minus 24. And now I'm 3 times everything inside the brackets, so 3x minus 12. So 3x minus 2y. Then I'm adding 24, so it's going to be plus 12. And then that is that for part A. So for part B, the point A lies on H. Okay, so it's on my xy equals 48. It's kind of obvious. The normal to H at point A is parallel to PQ. So the normal, so the gradient of the normal is going to be 3 over 2 because it's parallel to PQ. And we've got to find two possibilities for A. So xy equals 48. So let's first write this like this, and then let's differentiate to get my effectively gradient. Now, because the normal, so this is the gradient of the tangent, m of the tangent. So m of the normal will be flip this and change the sign. So I've got now x squared over 48 equals to 3 over 2. So x squared equals 72. So x equals plus or minus square root of 72, or plus or minus 6 root 2. So that's my x value, and then my y value. So if I put that into xy equals 48, 6 root 2y equals 48, y equals 4 root 2, or y equals minus 4 root 2 when I put in the negative 6 root 2, y equals 48. So a is 6 root 2, 4 root 2, or a is negative 6 root 2, negative 4 root 2. And there you have it. Right, let's look at question 2. Okay, question 2 gives me the point P, parabola, and rectangular hyperbola. Parabola is equation C, rectangular hyperbola, equation H. Find the coordinates of P. So I think what we'll do is substitute P into C. So y squared equals 16x. So that's 8t squared equals 16 times 4t squared. So 64t squared equals 64t squared. Okay then, that's not going to work. Let's try putting them into H. That's x, y equals 4. So 4t squared times by 8t equals 4. 4 times 8 is 16, 32. T cubed equals 4. T cubed equals 4 over 32. 4 goes into 4 once, 4 goes into this 8 times, so t is 1/2. There we are, now I've found t, so that one was a bust, but the second method worked. Now I've found t, p is 4 times 1/2 squared, and 8 times 1/2. So P is, so that's 1/4 times 4, so it's 1.5 of 8, which is 4. So P is 1,4. Now, next up we've got the normal to H at P meets the x-axis at N. Find the coordinates of N. So H is the rectangular hyperbola, so xy equals 4, and we're looking for the normal. So y equals 4x to the minus 1. dy by dx equals 4 minus 4x over x squared. Now we're going to substitute 1 in, so minus 4 over 1 squared, or minus 4. So the tangent gradient is negative 4. We want the normal. So the gradient of the normal is change the sign and flip. So positive 1/4. Okay, so let's find the equation. And then this is y minus 4 equals 1/4 x minus 1. Multiply by 4. So we've got x minus 4y plus 15. So that is my equation of the normal, and it meets the x-axis at the point n. So the x-axis is y equals 0. So we get x plus 15, or x equals negative 15. So it's negative 15, 0. Now we've got the tangent to C at P meets the x-axis at point T. So C is y squared equals 16x. So y equals plus or minus 4 root x, or better still, plus or minus 4x to the half, since we need to differentiate. So dy by dx equals, so plus or minus 2x to the negative a half. At x equals 0, dy by dx equals plus or minus 2. Okay. Now, at the point 1, 4, y equals plus 2 to the x to the minus a half. So it's going to be the positive one. Therefore, dy by dx equals a positive 2. So y minus y1 equals mx minus x1. Now, just on this point, you know that the parabola looks like this. So at the coordinates 1, 4 will be something like this. So the tangent is going to have a positive gradient. Okay, so you'll know that by the shape of the graph. Right, so y minus 4 equals 2x minus 1. So y minus 4 equals 2x minus 2, y equals 2x plus 2. So that is the gradient, that is the equation of the tangent, which is what we wanted to find. So t is on the x-axis, so at y equals 0, 0 equals 2x plus 2, 2x equals negative 2x equals negative 1. So t is negative 1, 0. Now next we have to find the area of NPT. So if we look at a very quick sketch, T is going to be there, N is going to be there, and P is going to be there. So the distance from N to T is minus 1 minus 15, so that's going to be 14. This height is going to be from 0 to 4, so it's going to have a height of 4. So area equals a half times 14 times 4, which is 28. Now, before we look at a couple more examples, or one more example I think, and a couple of questions, Don't forget to hit the like if you're enjoying the video so far. Hit subscribe if you haven't done so already. And if you are willing and able to help me out financially, please consider smashing the join button. It's very, very cheap. You can join for 1 month or more. So, have a look. Anyway, let's get back into the next example. Okay, here we have the final example. Now it's a past paper question. Let's have a look at it. So we've got the point P, and that is 4t 4 over t, lies on the rectangular hyperbola h with equation xy equals 16. Show that an equation of the tangent to h at P is x plus t squared y equals 8t. Okay, so I'll just make a little bit more room and then we'll work on A. So we have the equation xy equals 16, so y equals 16x to the minus 1. Now if I differentiate this, I get minus 16 over x squared, or minus 16x to the minus 2. Now we have to find the equation of the tangent, so the gradient at this point is minus 16 over 4t, and that's squared, because that's what our x value is substituted in. So it's minus 16 over 16t squared. These cancel, so it's minus 1 over t squared. Now, we need to substitute in to this equation. Y minus y1 equals mx minus x1. So y minus 4 over t equals minus 1 over t squared times by x minus 4t. So, I think first things first is multiply up by t squared. So that'll give me t squared y minus 4t. And then I've just got the minus 1 times everything. So minus x plus 4t. So x comes over this side. And then this negative 4t goes over to that side to become 8t. And that is then shown exactly, what we had to. There we have it. Okay, right, let's look at the next part. So the tangent to h at the point A and the tangent to h at the point B meet at x with y coordinate 5. X lies on the directrix of the parabola with C with equation y squared equals 16x. Write down the coordinates of x. So y squared equals 16x, and this is of the form 4ax. So 4a equals 16, a equals 4. So that's the focus. And then the directrix is x plus 4 equals 0, or x equals minus 4. So x has y coordinates 5 and lies on the directrix. So therefore x is minus 4, 5. Okay, so the next step is to find the coordinates of A and B. Now, A and B are the points where the tangent to H, which then goes through X. And this is the equation of the tangent to H. So that's where we're going to start. X plus t squared y equals 8t. And we're going to substitute in our coordinates of X. So that coordinate will go in and it should give me then two values of t and therefore the coordinates of A and the coordinates of B. So minus 4 plus t squared times 5 equals 8t. So we've got 5t squared minus 8t minus 4 equals 0. So using my calculator, I got x equals 2 and x equals minus 2/5. Okay, so I can actually go backwards from these. So x minus 2 equals 0, or 5x plus 2 equals 0. So x minus 2 is in one bracket and 5x plus 2 is in the other brackets. And just double check in case this, this is a fraction, it could have simplified. So 5x squared, 2x minus 10x gives me minus 8x, and minus 2 times 2 is negative 4. So there we have our values of, it's not x, sorry, our values of t. Let me just fill this in. T, T, and T. Sorry about that. So we've got our two values of t. Now we substitute in for the 4t and the 4 over t. So A will be, well, it doesn't tell me which one's A and which one's B, so these can be either way around. So 4 times 2 and 4 over 2, and B will be 4 times minus 2/5 and 4 over minus 2/5. So A is 8, 2, and B is minus 8 over 5, minus 20 over 2, so minus 10. Now, final part, deduce the equations of the tangents to H which pass through X. So all I need to do now is substitute A and B into this equation of the tangent. So it's not too difficult really. But since we want the equation in terms of X and Y, we're gonna substitute in t equals 2, and then we're gonna substitute in t equals minus 2/5. So the 2 points that got the coordinates for A and B, the t values, we'll substitute them into the equation now. So x plus 4y equals 16. So x plus 4y minus 16 equals 0. And x plus 4 over 25y equals minus 16 over 5. So multiplying by 25, we get 25x plus 4y equals minus, now 16 multiplied by 5 is 80. So 25x plus 4y plus 80 equals 0. And that is the end of the question. So it's, it's about applying everything that you know up to this point, isn't it? And that's what I'm going to leave you with. One or two more questions. I haven't decided yet. I'm going to look for some past paper questions. I'll pick a couple out and have a go at them. So here are two exam style questions, but they're actually past paper questions, not exam style. They are past paper questions. Have a go, pause the video, have a go at them. Answers will be at the end of the video. Okay, the point P lies on the parabola C. With this equation, so it's just general equations, where A is a constant, the tangent to C at P cuts the x-axis at A, find the coordinates of A in terms of A and T. So we have y squared equals 4ax. That's the equation of the parabola. So y equals the square root of 4ax. So y equals 2 root ax to the half. dy by dx is... So half comes down, so that cancels with the 2. So root ax to the minus a half. So that's the gradient. Now at the point P, x is at squared. So I'll just write this as root a over, root x. So dy by dx is root a over at squared square rooted. That's root a over root a t, and then so that's 1 over t. Now substitute that into y minus y1 equals mx minus x1. We get y minus 2at equals 1 over t x minus at squared. So I'll multiply through by ty minus 2at squared equals x minus at squared. Take everything to the side that x is positive, and I get x minus ty. Now I'm adding 2at squared to this, so it's going to give me plus at squared. Now it cuts the x-axis at point A. So when it cuts the x-axis, y equals 0. So when y equals 0, we get 0 equals x plus at squared. So x equals minus at squared. So the coordinates of A are minus at squared, 0. Now B, or just before B, the normal to C at P cuts the x-axis at point B. So now we've got to find the coordinates of B. Well, we've got the gradient of the tangent. So the gradient of the normal is change the sign and flip. So it's minus t. So y minus y1 equals mx minus x1. So y minus 2at equals minus t times x and at squared. So y minus 2at equals minus xt plus at cubed. Now, it hits, coordinate B, it hits the x-axis, so when y equals 0, we get minus 2at equals minus xt plus at cubed. So xt equals 2at plus at cubed. X equals, so dividing by t, 2a plus at squared. So that is my x value. So the coordinates of B are 2a plus at squared and 0. Hence, find in terms of a and t the area of the triangle APB. So area of APB is a half. Now the base of the triangle is along that x-axis, so it's A and B. So we want to do one, take away the other one to find that distance. So let's go with 2a plus at squared minus at squared. That'll be the base, and then the height will be this one, because these two are both at 0, so the height will be 2at times 2at. So a half times 2a plus 2at squared times 2at. So a half times, now if I times the 2at by these two, I'm going to get 4a squared t plus 4a squared t cubed, which is 2a squared t plus 2a squared t cubed. Or I could take out 2a squared t, and we get 1 plus t squared inside the brackets. Okay, so either of those will be fine there. Now this one we have a rectangular hyperbola with equation xy equals 9. Lines L1, L2 are tangents and both have a gradient of minus a quarter. We have to find their equations. So xy equals 9. Let's actually move this over. So y equals 9x to the minus 1. dy by dx equals minus 9 over x squared. And then this equals minus a quarter. So timesing by 4, we get 1836. So minus 36 equals minus x squared. X squared equals 36. X equals plus or minus 6. Now, substituting that into xy, so xy equals 9. So when x equals 6, 6y equals 9, y equals 9 over 6 or 3 over 2. And when I substitute in minus 6, we get y equals minus 3 over 2. So our two coordinates are 6, 3 over 2 and negative 6, negative 3 over 2. That's going to be the coordinates for the gradients where they hit the rectangular hyperbola. So that, along with the gradient, means that we can now find their equations. Now, believe it or not, this is worth 11 marks. How this is 11 marks, I do not know. So y minus y1 equals mx minus x1. So y minus 3 over 2 equals minus a quarter x minus 6. Multiply it by 4, so 4y minus 6 equals minus x plus 6. Take it to the x being positive side, so on the left, x plus 4y minus 12 equals 0. So that's that one. Then y minus y1 equals mx minus x1. So y minus 3 over 2 equals minus a quarter x minus 6. So y plus 3 over 2 equals minus a quarter x plus 6, times it by 4. 4y plus 6 equals minus x minus 6. Again, take it to the side where x is positive, so x plus 4y plus 12 equals 0. And that is an 11 mark question. Ridiculously easy for 11 marks, I think. Anyway, that's the end of the video. If you found it useful, smash that like button. If you haven't subscribed already and you wish to see more videos, hit the subscribe button. And if you're a long time viewer and are willing and able to help me out a little bit financially, then hit the join button. It's very cheap. Join for a month, join for more than a month. Totally up to you. Right, see you in the next video. Well, I say see you, you never see me. Hear you on the next video, I suppose. Goodbye.